Good morning students. Today we'll learn how to draw the graphs of inverse trigonometric functions. It is an activity given in 12th standard. Okay, let us begin by plotting the graph of y equals to sine x first. So this is the x-axis and y-axis, and the graph of sine x goes like this, like a wave structure, from 0 to 2 pi in the right hand side and minus 2 pi in the left hand side. So this is the graph of y equals to sine x. Now we have already discussed, to be invertible it is very much essential the functions to be 1 and not. So here for that I have drawn a straight line, but I see those 2 points they are matching. So in that case, for testing that, you must be having those 2 points, they should not be cutting, or a line should not be cut at 2 points of the curve. So this is not 1 in the total range as a whole. Now let us see when it is invertible. So let us draw this figure. This is the graph of sine inverse x in this range, and also you can see this is not a function, because in function we test like drawing a vertical line, and we see if for a single value of x we have 2 particular values, it is cutting at 2 points, it is also cutting at 2 points below. So the blue line is cutting at 2 points, so it should not be there. So this is not also invertible function. But let us consider this special case. Suppose I draw the sine x again, graph of sine x, and I know a function to be invertible it must be 1 and 1 2. For that, let me choose this portion of the curve. This is negative pi by 2 to pi by 2. Now can you see, whatever the portion is there, the graph shows monotonic behavior. So now let us have this one. Draw it. This portion, this is completely increasing, it is monotonic, this is not turning at any point, hence it is 1 from minus pi by 2 to pi by 2. And you know that the branch of sine inverse x is minus pi by 2 to pi by 2. Draw the horizontal line. Can you see it is cutting at only 1 point, hence it is 1 and 1 2. So this portion you take, and for drawing the graph of sine inverse x, again you take the help of another graph, and the branch becomes minus pi by 2 to pi by 2 for sine x. Now let's come to the second part of the graph. Here just take the line like this. How I drew this line? So let us discuss. This is very important. How to draw? You just draw a blue line here. This line shows y equals to x. Remember, a function and its inverse are always symmetric to each other with reference to this line. So if I take this line, then I got this curve as inverse function. So just you rotate it anticlockwise and you get this shape of this curve. So here this side y equals to sine x has the domain minus pi by 2 to pi by 2, and range is here sine inverse x, this range will be also minus pi by 2 to pi by 2. So this is how we plot the graph of sine inverse x. Let me revise it. So the range of sine inverse x lies between minus pi by 2 to pi by 2, and it is symmetric about this curve y equals to x, and this is the mirror image. You can say a function and its inverse are the mirror images of each other with reference to the line y equals to x. So let me talk about the domain and range. For sine x, domain is this, range is this, and for sine inverse x, the range is this and the domain is this. You can see they are exchanged with each other. Now let's come to y equals to sine inverse x. We have plotted it, and look at this. This is sine y equals to x. In other words, when I interchange them, so this is called also in other words arc sine x, and we write it in this pattern. Now sine inverse x, it is equal to 1 by sine x or not. Let us test it. So this concept is true or false. Let us check it. We know x inverse equals to 1 by x. Generally confusion arises that whether sine inverse x is 1 by sine x or not. Now Sin x whole inverse can be written by 1 by sin x, not sine inverse of x. So you can see clearly the difference between sine inverse x and sin x whole inverse. There is a difference in writing both the notation. So this concept must be clear to you. Now sine inverse x, it is equal to arc sin x. It is generally told as arc of sin x. ARC stands for arc. So sine y will be equal to x. This is the meaning of sine inverse of x. So we do not write general arc many times, we just write inverse. So that notation should not be understood, that is 1 by sine of x. So here f inverse x, and here sine in x whole inverse is 1 by sine x, and sine inverse x is written as arc of sine x. I think I am getting clear in this concept. So now let us come to the graph once again. This is the graph. Remember whose graph it is? I think it is the graph of y equals to cos x. Now let us take this portion for the inverse, because I need a monotonic part, either increasing or decreasing, should not turn at a particular point. Now for cos inverse x, if I say I can take only this portion to be monotonic, that is 0 to pi. If you remember the branch of cos inverse x, it is equal to 0 to pi. That means we can get the range of cos inverse x from 0 to pi. Now I have taken the domain of cos x, and here I have taken the domain of cos inverse. Now if I draw this green line, I saw it is cutting the curve at one and only one point. So here look at this portion of this curve, it is completely going up and down, not monotonic, but I have taken the second graph, I have taken a portion in which it is getting monotonic in nature. So let me take that portion for drawing the graph of inverse or cos inverse of x. So look at this, 1 to minus 1, it is getting monotonic. So I will take the value of y-axis into x-axis there. This is also another important thing. For drawing the inverse, y and x are interchanged with each other or exchanged with each other. Now as I have told you, the graph is synchronous about y equals to x. So now let me draw this portion, then this will be like this. Now look at this, the range is 0 to pi and the domain will be minus 1 to 1. Look at cos x and cos inverse x, the domain and range, they are getting exchanged. So this one domain minus 1 to 1, big bracket it should be, and the range is 0 to pi, and this is the shape of cos inverse of x. Now let's come to the next graph. Try to understand it carefully. For tan x, let me remind you regarding the construction of tan x. Now this is the graph of y equals to tan x. This is, and the blue lines, they refer to the lines minus pi by 2 to pi by 2. So it goes like this, tan x, because at tan pi by 2 it will go to infinity, it should not touch it. Now if I draw a green line, you can see clearly it is cutting at only one point. So that means it is 1 1 and onto. So let me take the portion minus pi by 2 to pi by 2 for plotting my curve. Now draw the green line, you can easily see that it is cutting at 1 and only 1 point. Now let us take this portion for plotting our inverse graph. This is the graph. This is minus pi by 2 to pi by 2. This is the graph of y equals to tan x, not tan inverse x. Now after that you write the values minus pi by 2 to pi by 2. Then this is the domain. This is minus pi by 2 to pi by 2, and the range, this is minus infinity to plus infinity. Now for the plotting of tan inverse x, let me plot another graph. Look at this. This is x-axis and y-axis. Draw these horizontal lines vertical lines in the first figure as horizontal lines in the second figure. So, and write the values. The below one will be negative pi by 2, and this is y equals to tan negative pi by 2, and the upper one will be y equals to pi by 2. So, to plot it, let me draw this one. This will go like this only, just invert it or rotate it, you will definitely get the graph. You can see they are the mirror images of each other with a 90-degree of rotation. That means y axis is converted to x axis and x axis is also converted into y axis. Now the range goes like this, minus pi by 2 to pi by 2, and the domain goes minus infinity to infinity. You can see easily that the domain and range are getting exchanged with each other. So this is how we plot the graph of various inverse trigonometric functions. This is all for today. Thank you very much.